We've all seen captions. They do one job well, translate spoken words into written words, so anyone with no access to audio can follow along what is being said. This may include individuals who are deaf or hard of hearing, but also hearing individuals with temporal or situational impairments. However, they are an imperfect translation. There's a lot going on with audio, so while captions can hope to include all words, anything that lives between words is missing: tone, rhythm, emotion, etc. In other words, the cues that tell a listener whether something was said with sincere, sarcastic, or furious intention. Rich captions are a recent expansion to traditional captions that work by translating into visuals these extra dimensions through which speakers modulate their voices. They work by slicing a speaker's voice through computational processes, extracting key features that we can translate into visuals that can be then overlaid into captions. Given that there are many different ways this can be done, past research has worked with the deaf and hard of hearing community to look at which features are most important to include and which visuals best communicate them. Researchers have found, for instance, that informing viewers of a speaker's emotions is more effective than showing them acoustic features such as loudness and pitch, and that these are ideally shown through properties such as font color and weight. There's a caveat here, though. Most of this research has been done in a Western context, predominantly in the United States. Not only, even if we do consider research done with different regions, languages, writing systems, and cultures, there are enough methodological differences to make direct comparisons impractical. Why should this matter, though? While there is a lack of research that looks into this, findings from other fields point to a high likelihood that cultural and linguistic factors could shape how deaf and hard of hearing individuals relate to rich captions. For one, we know that visual elements such as color and typography are profoundly influenced by cultural factors. There are many examples where, for instance, a certain color scheme would be understood as positive in some regions, but negative in others. Similarly, we could imagine linguistic factors and even the graphemic qualities of different writing systems to matter as well. Different languages have different ways of contrasting and highlighting semantic and phonetic differences. All of this put together led us to our current study, aimed at looking at how these differences could influence the perception and preferences of deaf and hard of hearing individuals towards rich captions.
The main research goal of this study is to explore how cultural and linguistic differences influences the design and perception of customized captions. We focused on the two distinct groups of deaf and hard of hearing participants. One group consisted of English speakers from North America, and the other includes Korean speakers from South Korea. The two languages differ in several ways, especially in how prosody is conveyed and interpreted. In the United States and Canada, we invited 28 native English speakers. In South Korea, we worked with 21 DHH participants. We conducted our user study using a web-based prototype interface. This tool allowed the participants to design captions by mapping prosodic features of speech to different visual styles. There are 5 key prosodic dimensions in our prototype: loudness, pitch, rhythm, arousal, and balances. These 5 features were represented using 7 distinct caption style options. Participants were able to decide which prosodic features they wanted to map to each style. The style is background color, baseline shift, font color, font size, font weight, opacity, and letter spacing. During the caption design phase, participants were able to select the mapping between the prosodic features and style options. They could immediately see their choices applied to the video caption in real time. Participants were able to play and replay each video as many times as they needed in order to fine-tune their design decisions. They could also select None for style option if they prefer no special styling for a given prosodic feature. Here's a step-by-step look at how our user study was conducted. First, we collected demographic information to understanding participants' basic backgrounds. In the tutorial session, we explained each prosodic features and style options and demonstrated the interface with a brief explanation. During the video assessment stage, participants rate each video's tone, mood, and emotional content and wrote down their impressions. During the caption design task, they created their own caption design and confirmed each of their mapping decisions as they went. After finalizing a design, participants moved to the design rationale stage, where they briefly explain why they made those choices. Lastly, in the post-interview session, we conducted semi-structured interview to explore a few key themes.
Our findings showed that North American and Korean participants had common but also different patterns across the speech features. Some patterns were shared across both groups. For example, both North American and Korean participants tended to visualize dimensions related to speech emotions. This finding aligns with previous research and suggests the potential existence of universal patterns. However, there were choices that were differed across groups. The prosodic features of pitch and rhythm in particular had distinct style choices. We also discussed the speech elements that has been most frequently selected. Especially pitch was most common choices for Korean participants but was almost avoided by North American participants. As we elaborate in the paper, we hypothesize that this contrast may stem from linguistic characteristics of the Korean language. We also discussed the most common style choices by participants. Style choices were common for features that shows intensity and emotion, such as balance with font color, loudness with font size, and arousal with font weight. However, style choices for rhythm and pitch were differed by the two groups. The difference highlights that speech accessibility is a culturally bounded phenomenon. In other words, designers and developers must conduct research with the specific populations they aim to serve. We therefore suggest 3 design implications for accessible captioning tools for deaf and hard of hearing individuals. First, offer gradual and context-aware customization. Second, provide a reasonable default but accommodate variation. Third, explore future integration and personalization. Lastly, we want to thank our team, Caluã, Roshan, and Matt from RIT, SooYeon, JooYeong, and Jin-Hyuk from GIST, and Sue and Khai from the University of Toronto. Please check our GitHub page for the prototype and more information. Thank you, everyone.